Okay, so I'm going to get started on the queries demo here. I'm going to use these first three data frames for our queries, and then we'll get into joins and relates after you watch the joins and relates lecture, and then the same thing for adding fields and the field calculator. We'll kind of come full circle on all three of these through these demos. So I'm going to start here with the feature attribute query. You can see that if I expand this, I'm going to switch this over to list by drawing order to simplify the interface here. I've got a shapefile of Baltimore County land use land cover, and I can open that up quickly, and I can see that I've got nothing showing here. If I come down and I say show all records, it shows everything for the different land use codes and the different acreages. So I've only got a little bit of information, but enough to be useful for doing some basic querying against this data set. So like we said in our lecture, if we wanted to select for a certain criteria, let's just say that I wanted to select LU code is equal to 21, which again is me selecting for all of the cropland in Baltimore County. When I apply that, I see that I get all of the 21s selected. I'll just say OK and open that up quickly and see that 583 records are selected of the over 5,200, and we can see that some of them are going to be highlighted in blue. If I click this button down here that says show selected records, we'll see that I've got all my 21s selected. But remember what I said about selection methods earlier. Maybe I selected for all 21s, but I meant to select for only 21s that are greater than 250 acres. Again, if I open up that attribute table, you can see that all my 21s, some of them are well below 250 acres. So I can come back into my selection by attributes, and I can see that it saves my query in there, and I can say, well, I'm going to run a new query here, and I'm going to say and acres is greater than, I'm just going to put a space in there and say 250. That's running an entirely new query. So it'll grab all the 21s and all the acreages of greater than 250. I could run it that way, and again, I'm running a whole new query. One thing that I can do though is I can actually chop off what I did originally, and now instead of creating a whole new query, I can just say select from the current selection, which is all the 21s, only the 21s that are greater than 250 acres. So when I apply that, you can see that my selection set is going to get much smaller. So that's one of the ways that you can interact with these queries, with these attribute queries, to ask a question. And we're going to go move on to the table attribute query, because we can query flat files as well. And we're going to see how we're going to use the data that we query here later on in our joins and relates demo. However, I did want to point out one thing about using the AND or the OR statements here. If I said LU code is equal to, and I said 21, and then I said and LU code is equal to 22, you might think, well, hey, great, I'm asking for all 21s and 22s. Different types of agricultural land uses. The problem is that there are no cells in the LU code field that are both a 21 and a 22. So that would return basically nothing. So I'm going to create a new selection here and apply that, and you can see that I get nothing. But if I were to change that to OR rather than AND, I'm basically telling it I want anything that has a land use code of 21, or if it's got a 22, grab that as well. And so I can create a new selection and run that query, and you see that it returns all of my 21s and all of my 22s. So those selection methods are very important. Depending on how you want to select your data, what the method is going to be very critical. So I'm going to go ahead and close that. I'm going to clear my selections. This is my clear selected features button, and I'm now free and clear of that query. So I'm going to go ahead and slide over to the table attribute query, and when I activate that, you're going to see that my window is empty. That doesn't mean I don't have data in it. That just means that I have no data that has points, lines, or polygons, no spatial data associated with it. So I'm going to switch to my list by source, and now you're going to see that the path to where my data is located is contained within there. I've got a table in here called US Demographics, and I have one called Maryland Demographics New. This is one that I created earlier. So I'm going to go ahead and open up US Demographics, and you see that I have 24 records selected. So I'm just going to go ahead and clear those out. And you can see now I'm going to sort these ascending so I can show them to you by state. I have a bunch of information, a bunch of demographic information for each county in the United States. This is Alabama, down to Colorado, Georgia, Maryland's in there somewhere. And that's what we're going to do, is we're going to query just for Maryland. And this is all demographic information. So you can see different races, different ages and ethnicities, age groups. And so we have some information here that we can then use as part of our other demo on joins and relates. So what I'm going to do here is I'm going to close out this table, and actually I'm going to open it back up because I want to query for just the Maryland counties. So there's 23 counties and Baltimore City, so 24 jurisdictions. So when I come in here, I'm going to actually use this table options button to do select by attributes. I wouldn't come up here and use selection because that's for selecting data within your data frame, but in this case I'm selecting from within the table. And so I'm going to come in here and I'm going to say state name is equal, and again I can use get unique values. There's only 50 values for the different states, and I'm going to say Maryland. And when I apply that, I can see that 24 records are selected, and if I either scroll down to Maryland visually here, there's my 24 selected Maryland, or I can just go ahead and click this button that says show selected records, and that isolates my Maryland counties. Notice that the county name is not one of the fields listed in here. We'll revisit that in one of the future demos for joins and relates, but right now what's really key is that we understand we have a subset of that larger 3,219 records. And so what we can do is we can come up here and we can hit the pull down and go to export, and we can export that out to its own table, so that instead of working with all 3,200 records, we're only working with the 24 that we're interested in. But you'll see that I have a couple that I've already created in the past here. I'm going to use this Maryland Demographics New as an example, but we could write that out to its own DBF file, and again that would be a flat file as indicated by these different looking icons rather than seeing a shapefile icon, and that's again just tabular data that we're going to do something with. So I'm going to cancel this and close this, and we can see that if I had exported that and gone through, I would have wound up with a new table that is just the 24 records. And it is just a coincidence that our state FIPS code, which I'll explain what FIPS codes are in the next lecture, happens to be 24. But these are uniquely identifying codes for the state of Maryland and also the counties within Maryland that we're going to use in a future demo when we talk about joins and relates. But for now, just kind of keep this in your back pocket. Remember that we're going to come back to this table as part of this demo. For now, we're just going to go ahead and switch over and just give you an example of doing a spatial query rather than an attribute query. So you can see I got a couple of different layers working here. I'm going to switch back to my drawing order instead of showing them by the path, by their source. And so we have CCBC Essex campus here, and we have an aerial photograph underneath, and we can see our neighbors to the south here, Franklin Square Hospital. And then I'm going to do an interactive query here to select just the buildings within our main part of campus. So I just dragged a box around that. So that's one of those an example of one of those interactive queries that we were talking about within the lecture. So I've selected those. I now have a subset of all the buildings. You can see a bunch of them are not selected. This is what I'm focused on here. So I got a call several years ago. Actually, this was a real world question. Jamie, what's the average elevation of the core area around where our buildings are on campus? So I can turn on an Essex CCBC Essex contours layer, and you can see these individual lines here indicate elevation. So I can click on an individual line and I can see that along that line we're at 146 feet above sea level. So the question came again as what is the elevation of our area around the core buildings. So I can go and do a select by location, and I can say, again, reading this like a narrative, I want to select from the contours that interact in some way with the buildings. In this case, I do want to use the selected features, the 18 features that are the buildings. If not, if I unselected that, it would actually query it against the entire pink buildings data set, but in this case I do want to use those 18 features. And this is what I was talking about, the spatial selection methods that I showed in the lecture. There's only 5 of them that I put in there, but we obviously see that we have several different interactions between the layers that we can choose. In this case, I'm going to say the target layers, in this case, which are the Essex contours, are within a distance of the source layer being the buildings, and I'm going to specify 100 feet. So based on this selection, it's going to select from the yellow layer of contours. And when I do that, I'm going to say OK here, and I'm going to turn off the buildings for clarity's sake. And you can see of all these yellow contours, only these are the ones that came within 100 feet of that building layer. Now what I can do is I can actually open up that attribute table, and I can see which ones I have selected. In this case, I have 171 out of the 3,636 records that represent all the contours within my entire data set, and I can do some statistics on it. In this case, my lowest elevation is 164 feet above sea level, and my highest is 192. When I run statistics on that, just by right-clicking on the elevation field and doing statistics, it gives me some quick results here, which can be very useful. So again, there's my minimum, there's my maximum, and in this case, my mean is 180 feet. So the average value of all the contours that I have selected is about 180 feet. And of course, we've got some rises and some dips and falls in different parts of the campus, so the elevation is obviously going to change. But that was enough to call the facilities gentleman back and say, hey, we're at about 180 feet above sea level, give or take a few feet in either direction, and he was perfectly happy with that. So that's a really good example, sort of a real-world example of how we can do a spatial query to answer a question very quickly. It took me about 5 to 10 minutes to go ahead and pull that data together, run the query, and give him a call back and give him his answer. So that wraps up my spatial query lecture, and so what we're going to do is we'll move on to the joins and relates demo, excuse me. We'll move on to the joins and relates demo and use again the table, the Maryland attributes, the demographics table that we exported here within the context of this demo. So you can see that we have the state of Maryland and a bunch of counties with not so much information, but this piece of information is really the key to be able to get some of that information over to our Maryland counties, and we would do that using joins and relates. So that's where we're going in the next demo, but for now you're going to want to move over to the joins and relates lecture, get the lowdown on that, and then we're going to come back and watch the demonstration on how to do joins and relates.